I've taken one question that is based on parabola and specifically based on shifting the origin. So as you can see, I am retracing the path of a parabola whose vertex is origin, that is 0, 0. Let's mark this point as V, and let's say this be its focus. As of now, we can ignore its exact point, and then we can draw its equation, directrix. As you know, directrix in this case is minus A, that is opposite side of focus. Now, what will happen if I change the vertex from 0, 0 to a new location? For example, I shifted it here to say 1, -2. What you can see that on shifting it, shifting the vertex, you can see all its parameter is changing. F is changing, vertex is changing, then the equation of directrix has changed, and even the axis is changed. So this is what called shifting the origin. Now for solving this question, let's read what does it say. It says we have to find the vertex, axis, focus, directrix, latus, rectum of this parabola. So for solving this, you can see I have split into different parts. In the first part, we'll be converting this in the standard form of parabola and by the method of completing the square. So let's do the first part. This equation is y square is equal to 5x minus 4y minus 9. So I can rearrange them so as to apply the completing the square. Must be familiar. This is y square. I can split this 4y as 2 times y and then another 2 here to make it 2ab plus b square. B has to be 2. Now on the other side, it is 5x minus 9. As you can see, I've added 4 to the left. So should I do on the right? Now this will become y plus 2 whole square. And this is 5x. This is minus 9 plus 4. That is minus 5. Further, I can take y plus 2 whole square and we take 5 as common, we get x minus 1. Now in the next part, first we will see the general equation of this kind of parabola is y square is equal to 4ax. Clearly, y positive, negative, and x is positive. So this is the general form. Now, once we did completing the square and obtained what is the general equation of this parabola, the next thing that we are going to do is do some substitution for shifting the origin. Now, the origin, as you know, is being shifted from here to here. So let's say what I'm going to do is to put this value. We are going to put this small y plus 2 as capital Y and x minus 1 as capital X. So let's begin with x only. I'll write, say, put this x minus y is equal to capital X and similarly y plus 2 as capital Y. And we can obtain the small x with respect to capital X, as we know capital X, and we need to get the small x. So on transposing this minus 1 to the other side, it is capital X plus 1 and small y is going to be capital Y minus 2. Now, once we have obtained this, let's replace x and y over here to obtain the equation of the parabola. As I can see, the equation of parabola is going to be capital Y square is equal to 5, so it's 5 capital X. Right. Then we can compare these two equations with the standard equation. The equation so obtained with the standard equation, needless to say that we are going to replace 4a with 5. So on replacing 4a with 5, I'm doing on the other side. We can say that replacing this 4a with 5, I get a as, we are getting a as 5 by 4. Now, clearly, this point is 5 by 4. The first thing that we have to get here is the vertex. So first we will obtain the vertex with respect to origin. That means with respect to capital X, capital Y. And then we will obtain the vertex by shifting the origin to a new location, that is with respect to small x and small y, represented by this parabola. So here we see that the vertex is 0, 0, that is capital X, capital Y, capital X, capital Y, and we know that capital X, capital Y is 0. So we can say that the vertex here in this case is 0, 0. Now, if we get the vertex here, now we'll see if we have to get small x, small y. Now you can see here that on replacing this capital X with 0 and capital Y with 0, I'll get small x as 1 and small y as -2. So therefore, the new vertex or the vertex with respect to this parabola is going to be 1, -2. 1, -2. This is -2. I think I need to magnify this. I made space between these commas, so it was 0, 0. Now same here, replacing this x, capital X with 0 and capital Y as 0, we are getting small x as 1 and small y as -2. So this is the vertex of this parabola. Now coming to the axis, as you can see here, the axis is for the parabola whose vertex is capital X, capital Y. For this, it is x-axis itself, right? And you know that for x-axis, the equation is y is equal to 0. So I'll be writing here capital Y is equal to 0. Now for this one, you can see that replacing this capital Y with 0, I'll get small y as -2. Here, I'm replacing capital Y with 0, I'll get small y as -2. The next is focus. And to get the focus, that's most important here. You can see the focus for this of the form of parabola. This, you know that the focus is A only. That means here the focus will be in the form of x, 0. You must be familiar with this of parabola of this type. So x, as you know, is positive 5/4 in this case. So 5/4, 0. Now, once we get f, let's write down here. The focus here is, I need more space. Yeah. So we got this focus as 5/4. So we're writing here, this is 5/4, 0. Now check. Replacing capital Y with 5/4. If I do so, if I replace this capital X with 5/4. Replacing capital X with 5/4. So let's say what I'm getting small x as. If I replace this with 5/4. So this is 5/4 plus 1. That should give you 9/4. Yeah. So you're going to get this as 9/4 here, the focus. And similarly, replacing capital Y with 0. As you can see, capital Y is 0. So you are going to get this as -2. Replacing capital Y with 0, we'll get small y as -2. So we got the focus as well. After that, we can see the equation of directrix. So for directrix, this is what equation of a directrix for the parabola with origin 0, 0. As you must be aware that this is parallel to y-axis, and it is x is equal to other side of the -a, that is at the side of focus, that is it is in the form of x is equal to -a, and a, as I can see, is this. So I can say that the equation of directrix for this capital X, capital Y is going to be x is equal to a minus a, and a is 5/4. Now, same on the other case, you can see that equation of directrix in this case, well, you should remember we are representing this parabola. So make sure you're writing capital X. In this case, it is small x. Now, same here, we are going to replace this capital X with 5/4. Now, if I do so, this will be minus 5 by 4 plus 1 should give you minus 4 plus minus 5 plus 4, that is minus 1 over 4, right? We got this. This is minus 1 over 4 will be the directrix for the required parabola equation of directrix. We are left with one, that is the latus rectum. This is the latus rectum. Now for getting the latus rectum, let me show you something. The latus rectum is not going to change. And how is it? Let's say this being the latus rectum of this parabola represented here. So this is the latus rectum, which is 4a. Now, even if I change its vertex, its latus rectum will remain same as it is a length. And you know that this is not going to change. So the latus rectum, as you know, that latus rectum is calculated as 4a, and a being 5 by 4, it is 4 times 5 by 4, and that is 5 unit. So we'll be writing here latus rectum as 5 unit. And as I said, that latus rectum is not going to change. So this is 5 unit. So finally, we had to calculate the vertex, axis, focus, directrix, latus rectum of this parabola, and we got it. Vertex being this, axis as minus y is equal to minus 2, focus as 9 by 4, comma minus 2, and the equation of directrix as minus. Oh, you can even modify this in the standard form. You can see that in the standard form, you should have written like this. On transposing x to the left, it's going to be 4x, and transposing minus 1. Well, this should be the final answer. We always write the equation in the standard form. So this should be the equation of directrix. And finally, the latus rectum, which I said is not going to change, will remain same in both cases.